Hey there guys, how's it going? This is Mike coming back at you with a redo of a previously recorded video. Some of you may have noticed that some of our videos were posted on YouTube and they didn't have any sound on them. So we're going to get a little creative here. I'm going to provide some live commentary on the videos that were previously uploaded. I'm going to go through these videos giving you some commentary on what I'm doing when I'm going through these problems here. So let's just see how this turns out. Typically we concern ourselves with real valued answers where things are real numbers, but there are complex numbers out there. So we do want to take a look into these guys and get familiar with them. The number / letter associated with complex numbers is I. I is by definition the square root of a -1. This is the only time we take square roots of numbers that are negative. And thus, obviously, if you take -1 or the square root of -1 and then square it, the square root and the square cancel each other out and you're left with -1. And that's what I squared is equal to. If you do I cubed, that is just I squared times I, and I squared is -1. So we have -1 times I or minus I, and then I to the fourth is I squared times an I squared, so -1 times -1, or -1 squared, and that gives us +1. And we actually go through this cycle of values here when we go through these powers of I. There's I, -1, -I1, and that cycle actually repeats. So that's a little fun fact there, something to just sort of keep in mind. So just a quick sample here as to how this comes in. If you have the square root of -36, using our square root property, that's the square root of -1 times the square root of 36, and the square root of 36 is plus or minus 6. So that's going to give us plus 6i or minus 6i. And then we have the square root of a -71. So again, this one you can't really have the square root of 71 break down into something nice. So you just have to leave it as the square root of 71, but we can have that square root of -1. So that's plus or minus I times the square root of 71. In general, we have complex numbers that are of the general form a plus bi. A is the real part of our complex number, and b is known as the imaginary part. And note that every real number is a complex number. Every real number is just the a piece. So the set of real numbers is actually the set of all things of this form, this a plus bi form, but b is specifically equal to 0. So that part with the I does just get wiped out. But a and b on their own, just what we're substituting in there, are real numbers. It's the I that makes this thing complex valued. It's not very often that you have someone doing a live commentary over a previously recorded video, but hey, what the heck? Let's try something different. There is a special name that we give to the set of all complex numbers. It's a capital C and then a vertical line kind of going through half of it. So it's like a fancy looking C. These are all examples here of complex numbers. The first one, very straightforward, 5 plus 2i. A is 5, B is 2. Third one, second one is a complex number. A is 3/4, B is minus 1/6. And the third one is a complex number as well. Using our properties of fractions, that's 9 over 7 plus 13 over 7 times I. So A is 9/7 and B is 13/7. Yeah, just as you know, if you have the sum or difference of two things on the top and then you have one thing on the bottom, you can write it as thing 1 on top divided by thing on bottom plus or minus thing 2 on top divided by thing on the bottom. We have this notion of the magnitude or the norm of a complex number, much like we have the concept of the absolute value of a real number. Absolute value of a real number is the distance from the number 0. The magnitude or norm of a complex number is the sort of distance that the complex number is from the point 0, 0, from the origin, if that's ringing any bells. So the norm is the square root of a squared plus b squared. Very simple, very straightforward formula, not that hard to figure out. So if we work with a sample here, 5 plus 2i, A is 5, B is 2. We're going to calculate the norm or the magnitude of this guy, and it's going to be the square root of 5 squared plus 2 squared. Obviously, 5 squared is equal to 25. And 2 squared is 4. Add those up, you get 29. And we're taking the square root of that thing. So the norm of 5 plus 2i is going to be the square root of 29. So now some of the sort of basic operations. How do we add, subtract, multiply, and divide complex numbers? Adding and subtracting, it's very easy. You're just going to add or subtract all the terms without an I, and you're going to add or subtract all the terms with an I. So here, 5 minus 3i plus negative 2 plus 7i. I'm just going to combine the 5 and the negative 2, and then I'm also going to add up the negative 3i and the 7i. So 5 plus negative 2 is positive 3. Negative 3i plus 7i gives me a positive 4i. Very, very simple, very, very straightforward. Adding and subtracting, not that complicated. Nothing crazy happening there. Here we're taking the difference of two complex numbers. Still works the same way. You can either distribute that minus sign into each term in the second set of parentheses, or you can wait to do that until you've grouped all the non-I terms and all the I terms. But that's what I did. So we have 2 minus the negative 3, and then we have the 9i minus the 2i. So 2 minus a negative 3 is 2 plus 3, or 5, and 9i minus 2i is 7i. Multiplication of complex numbers. Still, overall, not that bad. It's not that hard. You're just going to FOIL it as if it were a product of two binomials, first, outside, inside, last. So if I multiply the first numbers in each thing, I have 4 times 6. Outside's 4 times I. Inside's negative 3i times 6. And then the last, negative 3i times I. So that's going to give me 24 plus 4i minus 18i minus 3i squared. Now, if we make a small substitution here, from earlier on in the video, we saw that I squared was equal to negative 1. So that last term there is actually minus 3 times a negative 1, or a plus 3. We also combined the 4i and the minus 18i to get minus 14i. So in the end, this is going to be a positive 27 minus 14i. This is a slightly nicer product here. In this case, we are just going to distribute the 5i into each of those two terms in those parentheses there. Just going to do 5i times 3 halves plus 5i times 8/5 I. So that gives us 15 halves I plus 8i squared. Again, I squared is negative 1, so that's actually a minus 8, and then plus our 15 halves I. So multiplication, really nothing crazy that we are doing here. Pretty basic, pretty straightforward stuff. Division of complex numbers. When we divide complex numbers, it can get a little tricky, but to do it, we need something called the conjugate. If you're not familiar with this term, if you have a complex number of the form a plus bi, the conjugate of a plus bi is a minus bi. We're just taking the sign that's in the middle of our two terms and we're changing it to be the opposite sign. Likewise, if you have a minus bi, the conjugate is a plus bi. And we are going to need this conjugate because if we have a complex number on the bottom of our fraction, if we have something with i's on the bottom, we need to multiply by the conjugate of that bottom. So you're given your complex number, you have something on the bottom of your fraction, you're going to multiply on the top and bottom of the whole fraction by the conjugate of what you have on the bottom of your fraction. So here, I have 3 minus I over 2 plus I. We need the conjugate of the bottom. The bottom is 2 plus I. Its conjugate will be 2 minus I. So I'm going to multiply on the top and bottom of this fraction by 2 minus I. And what this is going to do is it's actually going to make the bottom a real number. It's going to clear out the i's. So now we're taking the products, or the product of fractions, we multiply the tops and we multiply the bottoms. When we multiply out the top, there's some foiling that we have to do. 6 minus 3i minus 2i plus I squared. The bottom, 4 minus 2i plus 2i minus I squared. And now we do some simplification here. On the top, negative 3i minus 2i is a negative 5i. I squared is negative 1, so we have 6 minus 1, or 5. So we have 5 minus 5i on the top. The bottom, we have a negative 2i plus a 2i. Those cancel each other out. And then I squared is negative 1. So 4 minus a negative 1 is 5. So we have 5 minus 5i, but I can pull out the common factor of 5 from each term on the top and cancel that out with the 5 on the bottom. And in this case, we're going to get a pretty nice answer. We are going to get 1 minus I. So sometimes dividing complex numbers does give us a nice complex number, like we saw here. Many times, though, it doesn't give us something quite as nice. But the main thing is we don't want to leave things with i's on the bottom of our fraction. Much like when working with real numbers, we don't want to leave square roots on the bottom. That is just not as fun. So guys, that concludes our voiceover of this first video here on complex numbers. I don't know about you, but I think it went pretty well. So if you have questions or comments, please reach out to me, send me emails, texts, phone calls, whatever you have to do. Until the next video, take it easy.